So, hi, good afternoon. My name is Flavio. I work in information retrieval problems. Today I'm going to talk about information retrieval in social media search. I work with João Magalhães and my co-advisor is Jamie Callan. So today, because the presentation is so short, I decided to present you a demonstration of some of the algorithms in the form of an online search system. So this is jitter.io. Please do visit and try it. Suggestions are welcome. So this is, we're going to focus on social media, but specifically on Twitter, which is where the social media search problem is more visible. So because tweets are so short, you have less opportunity to match your query to the tweets. So searching highly relevant tweets is difficult because the words you use are not the same. So just to explain here the interface. So the query, you can see it from back there, but the query is Rio Olympics. So the top tweets are about the Rio Olympics opening ceremony, which is the moment that most people are watching about the Rio Olympics. So that's what our algorithm does. It finds the most bursty or more popular periods about an event, and it shows those high-quality documents. So another feature is that our system can leverage on the news to find words to augment your query. So you have Rio Olympics in there, but it could go into the news and add new words to the query. So on this side on the left, you have some suggested topics based on your query, which are regular news, sports, business, which are topics that are related to Rio Olympics, but also they are sorted. So you'd have a better chance or better results selecting sports and news than selecting the topic women or tech. So how we did this? There's a technique for expansion. There's a technique called pseudo-relevance feedback, where you search the full corpus and get the top 50 or something like that, and you extract the top words from that. So you estimate a relevance model, the words that you think are going to provide the best results, but that involves, I don't know how to, that involves two searches on the same big corpus. Okay, so our approach is to search on the news instead and also search on verticals. So here, topic and vertical, you can consider that they're the same concept. You search on news and sports instead of searching on all of them globally to get better documents for your query.
Thank you very much. Now I would like to know if any of you have any questions about this short talk that you would like to ask one of the speakers. No questions? Maybe you're right. All right. So, I think there is a small change in the...
Thank you so much for this invitation and also for waiting. So I'm Filipe Pleasure and I'm here to talk to you a bit about some of the work that I did while doing my PhD. And the topic of my talk will be social media reputation in the sentiment graph. So the focus of this work was on the fact that nowadays we observe that people share their opinions about mostly everything. And when they do so, they use specific words to affect their sentiments or how they feel about what they're talking about. And many times you do notice that they also mention entities. And when I talk about entities, we are talking about celebrities, brands, companies. So all these words are also used to affect their opinion. And another thing that we also notice is that a given word, if you say it's used to affect sentiment, for instance, think about the word excellent, it comes with different weights. So we call this distribution, in the sense that when we as a user, when we read a certain opinion, we do notice when there are words that have a higher impact than others towards how they feel about this, about their opinion about something. So this is the focus of this work. So the challenge is, how can we detect these words that are used to affect sentiments, and where are these entities as well? So here are two examples of what we have when we look at users' reviews. These are an example from IMDb. So it's a review about the movie Prometheus and a review about the movie Unleashed. And we as a user, if you look at it, even if you don't know the movies, we can instantly detect specific words that are used to affect sentiment. So here we have the words disappointment, uninspired, disregard. And these are the type of words that easily can be detected in a generic sentiment lexicon, because they tend to be used with the same polarity, so in this case, negative polarity, in different domains. However, if you take a closer attention on the reviews, we do notice that there are other words that are used to affect their opinion. For example, here in the second review, we have the movie Unleashed, and the user starts by saying, "Did you like Old Boy, The Bourne Films, Fight Club, Leon?" So what the user is doing here is making association between the movie Unleashed and all these other movies, which can be seen as entities, and they have a certain relation in regards to how he feels about the movie. So in this case, it was a positive review, and he's making a positive association between the movie Unleashed and all these other entities. So the question is, how can we do this? And one of the first questions was, is this available? Can we actually use something that is out of the shell and will give us the answer towards these questions? And one of the most important indicators is that, well, it's a subjective text. It's free text as well, so there are no rules. And what we see is that sentiment words can change according to the domain. For example, I've shown you just two examples from the movie domain. If you think about the word frightening, the word frightening in the movie domain might not be a negative word, but in another domain it is. It tends to be in many other domains, let's say so. So they have different directions. So maybe we need actually an algorithm that builds a sentiment lexicons for a specific domain. And another thing is that they come with different intensities. And again, this can change according to the domain. And finally, we do believe that specific domain jargon, specific words that are attached to the domain, so they will not be within a traditional sentiment lexicon, are highly important if you want to detect the sentiment of a given review of a user. So towards this goal, what we proposed was a method that we named by rank LDA. So it's based on the LDA algorithm, which is latent additional allocation. This algorithm is very well known on topic classification, in the sense that it's able to detect words that are highly important to a specific domain. And one of the advantages of this algorithm is that it does not require any manual notation. So if you give a collection of documents, it's able to detect different topics that are being mentioned and which words are more relevant to each topic. And what we propose here is to adapt this algorithm to our problem. So our problem is that we want to detect which words are used to affect sentiments, and what are also their intensities towards this different polarity, so this distribution that we would attempt to achieve. So I think this graph illustrates better what I just explained to you. So I told you that LDA is able to given a collection of documents, so you can think about the reviews as a collection of documents. We can feed the LDA with a collection of documents that the users gave a rating. So if you think IMDb, we have a rating that goes from 1 to 10. So this is what we can see in the axis. So we have a model for each of the ratings. So we did not tell the algorithm that we want to build a sentiment lexicon. We did not annotate any words, so it did not give a seed of words that we say, okay, this word should be positive, so expand from here. So this is fully automatic in this sense. And what we are able to do is, here in the Y's, we can see the probability of a given word belonging to each one of these models. So each one of these models computes different latent topics, and we aggregate all the probabilities of a given word belonging to these latent topics, and we give a certain probability of belonging to this latent topic. So this is more or less how we do it. And for instance, here we have the word terrible. And if you look at the word terrible, it has a high probability in the model of the lowest sentiment level. But while we look at the models with higher sentiment, we can see that this relevance decreases. And the same thing applies, for instance, for the word love, where in the lowest sentiment levels, it has no relevance at all, and its relevance increases while we look at the models with the higher sentiment. So this enables us to build up this distribution. So we know that the given word is not only positive or negative. We can make a distinction between the word awful and the word terrible. So here we can make a distinction between these two different words. So this is what I mean when I said we want to identify the difference. When I say this was an excellent movie, this was a good movie. So it's different. And we want the model to be able to tell us which words the users are using to affect their opinions. And here is again, here we're looking at the same thing, so in the Y's and X's. And I just want to show you some examples of what we are able to do. So here is an example for the movie domain, IMDb. We are able also to detect neutral words. So if you want to build a sentiment lexicon, we also want to remove from this lexicon the words that come with no sentiment. So they are relevant to the domain. So if you are looking at, for instance, I mentioned that LDA is a good model for topic classification. So we want words as watch, so this word is relevant for this domain. But it's not relevant in a sense if you want to detect a sentiment word. So you can see that its probability, it's very similar in a different sentiment levels. So we are able also to remove the neutral words from our sentiment lexicon. And finally, here I just want to show you an example of a word that is highly attached to the domain. Oscar in other domains might be even a given name, so it will not have any sentiment value, but in this specific domain it's highly important. And finally, still on the same graphs, what I want to show you here is that, well, so far I've been talking about the movie domain, but this also applies to other domains. So we used here the TripAdvisor, so we use reviews from hotels where people stayed in a hotel and they gave their opinion about it, so how they felt about it. And again, we're able to detect words that are highly attached to the domain, and we were able to observe this distribution. So as you can see here in the X's, we have a rating that goes now from 1 to 5. So these models are dependent on the rating that the users gave. Finally, to evaluate this proposal, we use these two different domains. I've mentioned so far many times the fact that we have out-of-the-shell sentiment lexicons. So you wanted to see, because one of the arguments could be, well, yes, you capture many other sentiment words, but do they actually improve the quality in a sentiment classification task or an opinion ranking task? So you want to see this. So we compare our method with these static sentiment lexicons. SentiWordNet has words with different weights. However, it demands that we use another algorithm to give us this, if it tells us it's positive or negative. Another thing that we want to show is that is it better if you also apply other algorithms that try our approach? So they are, like, let's say, it's a fair play comparing to our approach. So it will take the same strategy. However, we will apply their algorithm to compute the sentiment lexicons. And finally, we did the sentiment classification and opinion ranking. About this result, I'm just going to show you the results for the opinion classification. And I want to highlight two things here. So here we are looking at, in the Y's, we have precision. In the X's, we have the amount of words that the sentiment lexicon require to achieve that precision. And this is for the IMDb dataset, and this is for the TripAdvisor dataset. For all the tasks, we were able to show that either we outperformed the other approach or we had comparable results. And if you look at the results, see, these ones here are our models, so this is rank LDA. And here we have the other approaches, such as WebGP and labeled LDA. So what we can see is that we increased the number of words in the sentiment lexicon in comparison, but it wasn't that much, but it was enough to have a higher performance. And another thing is that this method here is TF-IDF. And one question that many times researchers asked me when I talked about this algorithm was, well, but did you try TF-IDF? Because they kind of relate this approach with the co-occurrence metric. So what happens, and this is what we did here, so we applied TF-IDF, and we can say that it shows a fairly good performance in terms of if we compare the overall performance. However, what actually happens is that it's not computing a sentiment lexicon. It's observing all the words that I mentioned in this domain, and it builds words that are relevant for the domain. So what does this mean? If you want to use this as a sentiment lexicon, it will not be applied. And again, our rank LDA only had 2.6% of the words that were in TF-IDF. So this was the work that we did towards the sentiment lexicon. And this led us to another work, which was how can we analyze the reputation of entities? And the reason for this was when we computed our sentiment lexicon, we noticed that there were many entities that were so relevant that they were in the top words for either positive or negative. So this is what I said in the beginning. So some entities become so relevant that they are used as a positive or negative reference. So the challenge here is how can we use this to see how they affect the public image, so the reputation of a given entity, and how all these relations between the entities will help us to compute this. So how can we see, okay, if you think about Harrison Ford, what is the reputation of Harrison Ford, and who were the other entities and sentiment words who achieved that, so who made it have that reputation. And I want to highlight this point here. This is very different from a task when we have a specific product. For instance, if you think about camera, and you want to see how the different aspects of this camera affect the reputation of the camera. So we can think about the weight, the quality of the picture. So it's different because these aspects are predefined, so we can expect that people, when they give their opinion about that camera, they're going to mention these different aspects. However, when you think about the reputation of an entity, this is not true. So many times people are creative, and they build up associations that many times beforehand we cannot predict. So how can we link the entities? Here I have two examples of sentences used by users. In the first one, the user says, I just came back from a special screening of Batman Begins, and I must say this is the best movie I have yet seen this year. So here we have the entity, which is the movie title Batman Begins, and the sentiment word best, which affects, has an influence towards its reputation. And in the second example, we have add to some of the best features of RoboCop, Batman Begins, Terminator 2, and you have one of the most satisfying comic books. So here we have the sentiment word, which affects the reputation of these three entities, and these three entities are influencing each other. And if we put this in a graph, we can have different nodes, where you have nodes that are entities, and you have other nodes that are sentiment words. And what we want to do is weight this influence to achieve, in the end, we can say, this is the reputation of Batman, this is the reputation of Christian Bale. And you can also know how we came to this reputation, because we'll be able to see which links, so the edges that were more relevant. To compute this, we applied a sort of a page rank approach. So in the beginning, all these nodes come with a certain weight. The weight is computed using the sentiment lexicon that I've just told you. So we have an initial weight for all these entities, and we will iterate the reputation of all the entities until they stop changing. So this means that if I have an entity E, it will start with a given sentiment weight, so given by our previous model. It will change according to its relations to the other entities, so according to the sentiment weight that was given to the other entities. According also, so this factor here is the semantic relation between the two entities. This semantic relation is built by a model that looks only on the entities that I mentioned together, on all the different reviews, based also, again, on its rating. And this is the co-occurrence, so the more often they occur together and they occur alone. So this is also to balance how relevant it is, this association. So we can increase the weight of one edge or not. So in the end, we have a certain amount of entities, and we say that they have this given reputation. One of the biggest challenges here was how can we evaluate this? So we did not have any data sets that was already annotated so we could answer to this question. So what we did here, we used crowdsourced techniques where we randomly extracted 2,500 sentences where our entity occurred together with another sentiment word. And we did the same where we had the entity occurring with other entity. And we asked annotators to tell us, first, what is the sentiment level of this sentence? And if they agree that that entity is being influenced by the other entity, so if the reputation of that entity, by being mentioned together in that sentence, has an impact. So given this annotation, we're able to evaluate our model. So this is what we did prior. So this is the sentiment lexicon, which is also part of this work. And to evaluate the reputation, what we did is we used the crowdsourced techniques, we did the sentiment classification problem, and we compared with different sentiment lexicons. When I say we did the sentiment classification problem, what we did was we look at different entities. So here we have Johnny Depp, Peter Jackson, Pulp Fiction, and Bruce Willis. And we had 50 sentences where Johnny Depp was mentioned positively, and we had another 50 sentences where he was mentioned negatively. So what we're saying is, if we have the reputation of Johnny Depp, but you also have the reputation of the other entities that I mentioned in this sentence, can we identify when it's being mentioned in a negative or positive way? Because this allows us to see these relations that I was mentioning just before. And in this graph, what we can see here is, in the Y's we have the accuracy, and in the X we have, in the last one is our model, so this is the entity reputation graph, and these three are the sentiment lexicons. We could see that we had a better accuracy, but also we were able to see that we were more precise when we made our predictions. So, for instance, if you look here, we can see that was a high uncertainty on these predictions, and here is the same. And our model was more certain, so we had a higher accuracy in as well. So to wrap it up, I also want to tell you. So I was told that this is also for PhD students that are starting their work, and I wanted to tell you a bit of how we can also use the work that we do here in the industry. So one of the things that I had the chance to participate was a challenge given by NOS and Microsoft, where they asked the students how they foresee the television of the future. So this work that I've just told you, so I showed you how we could predict the sentiment classification given a reputation, but I also, a reputation of the different entities, but also I was able to identify which other entities were relevant to compute this, right? So we did a demo where we had a central entity. Here we have Harrison Ford, and we can know which entities had a higher positive impact towards Harrison Ford's reputation and which one had a negative impact towards Harrison Ford's reputation. And what we said in this challenge is that why not use this while we are watching TV? We can know in real time, given a specific show, which other celebrities, other programs, even entities that people mention. So in programs, so when we have a reality TV show, many times they mention other entities. How people talk about this has an impact on the reputation of that program, of that specific entity. So this is what we can do with this type of algorithms. And this example here was also to show that it's not because I have a good reputation that, well, I better explain the example. So here we have the example of Anna Montana and Walt Disney. So Walt Disney, one of the negative entities towards Walt Disney reputation is Anna Montana. So Anna Montana is a character that appeared in many movies supported by Walt Disney. So it has a negative impact. However, if you look at the character Anna Montana, Walt Disney has a positive impact. So this is not like, for instance, if Anna Montana had a negative impact, the same thing does not hold the other way around. And finally, so I just told you about this challenge. I also did an internship, which I think it's a very good thing to do as a PhD student. We have the opportunity to work in a different environment, to get to know other researchers, and I think it's a great experience, even if later on when you apply for a postdoc, if you want to go to the industry, it has a very positive impact if you talk about this experience. And finally, all of this also allowed me to work right now as a data scientist at Vodafone. Thank you.
We have time for some questions.
I have two questions. First, if your Yahoo account has been hacked, is that every account?
No, I was safe.
Second question is whether your algorithm is smart enough to capture the negation of positive statements, let's say. This one was not good.
Yes.
Very good, maybe you rank. It's not good, it's not really positive statement. Does your algorithm is smart enough to capture these small nuances of...
So the algorithm itself detects a sentiment lexicon. So in the end, what we're actually doing is if you look at SentiWordNet, what you have is a set of words and you have their weight, right? So this is what we have in the end, the sentiment lexicon. The task itself, when we did the sentiment classification and the opinion ranking, it was taken into account, but this was computed. So we take into account if you have a negative word which inverts the polarity of that word. So this is taken into account in those specific tasks. Yes, in the evaluation it's taken into account, yes.
How well does it deal with sarcasm?
Well, sarcasm is another challenge, let's say. So I did not work with sarcasm.
Any more questions? Okay, so let's
Thank you.
So we'll just conclude and get closer to the microphone so that recording. So I will just conclude here. As you've seen, we just changed a bit the program. So I would just like to thank you all for being here and for presenting. Sorry for cutting some of the speakers during the flash talks, but I just have to make it faster. So thank you very much once again. If you have Yes. Also, you have some ideas about this format that we are experimenting. This is more or less the second time that we are doing it. So if you have suggestions for a different format or even different way to presenting, please just send it to us in the scientific committee. We'll be happy to accommodate some innovation in these events as well. We're planning to have another one for next year. Since whoa, this is speaking. We had a coffee break planned for the. Okay. We had a coffee break planned for before, so we'll just do the coffee break now with like a farewell coffee break. So just have some cookies and some coffee in the same room as before. So thank you very much once again. Thank you.